Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. So for today's episode, we have an absolutely fantastic guest lined up. She is called Jacqui Murray, and she is the Deputy Director at the Faraday Battery Challenge, which is part of Innovate UK. So welcome to the show, Jacqui. We're going to talk about all sorts of things to do with batteries, battery systems, battery research. I know, of course, the fantastic work that you've done at the Faraday Battery Challenge over the last few years, and probably set out a bit about what's going to happen there in the future, and introduce it to people. So thank you for joining us.
Yeah, nice to be here, Ryan.
So as has become a sort of custom for these interviews, could we kind of dive back and could you tell us a bit about your history and how you sort of got into engineering and how you came to be doing what you're doing now?
So I think I got into engineering because of two things, because I like maths and I like science. I found them easy when I was younger and found them interesting. And you didn't have to write long answers, which I thought was a great thing, I guess, when I was back in school. And then I won't say I fell in love with Nigel Mansell, because that would be wrong. I certainly fell in love with Formula One about the time that Nigel Mansell was there. You'll be glad to know I didn't fall in love with Nigel Mansell.
You did like the big tash.
I'm
Nige, I could see like that kind of doer, Yeah.
Oh, he was a fantastic driver. So I just really fell in love with Formula One. So I ignored the fact that I was much better at chemistry than I was physics, and went to do mechanical engineering. And then whilst I was doing mechanical engineering at Manchester, I suddenly realised that actually the materials elements of it made so much more sense.
Yeah.
And I really enjoyed that. And Manchester, it's actually pre-graphene in Manchester. That's how old I am, back in 1992. And I switched to materials and really didn't look back. I ended up, my first summer job was on Scunthorpe Steelworks, which was like land of the giants. And I just fell in love with the adrenaline rush and the complexity and just that feeling of making stuff that I think once you've had that moment, it's hard push to go away from engineering.
Yeah, well, I mean, that's steel, somewhere like Scunthorpe Steel Manufacturing, that is engineering on an epic scale that actually sort of we don't get all that much of in the UK. It's kind of, we used to be something we were really strong at, and then it fell away. So that must have been quite difficult for you as well, kind of male-dominated environment and like the most kind of, I mean, basically you could have been there on an oil rig, and I think that would have been like as macho as it comes for that sort of thing. So how was that?
I can't talk about offshore. I don't know. But what I would say is I remember walking out onto Scunthorpe Steelworks and feeling at home. So in that massive, awe-inspiring, volcanic, huge buildings that, like, one of the bays on Scunthorpe Steelworks about 3/4 of a mile wide, right? Just epic, as you say. Actually, I was made to feel welcome. There's a lot of banter, a lot of fun, but actually a lot of those teams work in very dangerous environments. And actually, one of the things that I realized very early on was just how much they cared. Maybe in a gruff, heavily tattooed, regal smoking way, Brian. But like underneath the humor, there was a real acceptance of what was quite diverse teams. So they might have been white men on the whole, but you had everyone from PhDs, mainly during the day, through to guys that actually weren't literate, and the shift managers were just brilliant leaders of teams of sort of 300, maybe 400 men working through the night, producing thousands of tons of steel. And it was just, I think it's one of those special places actually where you see real leadership. And even to this day, I'll still every now and again one of those shift managers' wise words will pop in my head in terms of what it really means to pull teams through difficult times, etc. So
yeah,
I fell in love with it, as you can tell, Ryan.
yeah, it's cool. And then the leadership bit there's interesting. It's not the first time actually that someone has said to me about the steel industry being quite a unique melting pot of the sort of shop floor through to PhDs, all kind of mixing it up together. But the safety angle as well. I mean, like some certain extent, in some industries you make a big deal about trapping a finger or something, whereas it's life and death every day, multiple times a day. In those sorts of industries, if you get it wrong, it's potentially fail. So yeah, big big focus on that. So then after that, where did you head off to?
So I did 10 years actually. I worked on Scunny, but then I went down to South Wales. I did predominantly technical and manufacturing roles. Got the degrees, got sponsored through my first one kindly by Scunthorpe, and then through a Masters of Materials Engineering and an MBA, and also got the Chartered Engineer. But I just couldn't secure those roles in manufacturing in South Wales. That seemed to be much more forthcoming in Scunny. So after 10 years, I decided that, you know what, I was going to go and work for the Environment Agency, which was my other love.
Okay.
But I stayed pretty much in the heavy industry side as much as I could. So ended up doing things like transposing the Industrial Emissions Directive, which the first sector through was iron and steel. Ended up being involved, being the lead official for a 2 gigawatt power station complaint to the European Commission, which meant us intervening and stopping them operating to the delight of RWE Power for about 4.5 months. But actually came up, I think, now with a really good outcome for the environment down there. So yeah, I've always managed to have pretty exciting jobs. We permitted Port Talbot Steelworks at one point, led the team doing that.
Right.
And then I think those things, you kind of get known, a lot of that is not dissimilar to how you'd engineer and deliver steel. I know it sounds crazy, it's complicated stuff, there's a lot of people stuff in there, and you have to pull those teams and that knowledge and gain the knowledge you need to move forward. And so I got known as, I guess, a bit of a fixer and got asked to then step in and do a couple of really crazy jobs in what had moved from the Environment Agency to Natural Resources Wales. So I even had 2 years doing internal drainage districts, which is basically low-lying floodplains that have managed waterways in Wales. And you might remember that the farmers weren't so keen on the Environment Agency on the Somerset levels. So I was over the border in Wales, merging the internal drainage districts into Natural Resources Wales. And it turned out I really liked grumpy farmers in across Wales and got on really well with them. And I suspect that was partly the steelworks background, right? They're very focused on cash flow. Yeah. They like to be involved in decisions. And it's that same sort of feeling that you can work together and get better outcomes that I think always sort of drove me. So that was summarized somehow about 14 years in the Environment Agency and RW and all of that. But as you can tell, I didn't really sit still for very long.
Yeah.
And this job popped up as head of advanced materials in Innovate UK, and I thought, you know what, I want to go back towards materials. That's really what had happened. I'd always got a bit too good at fixing problems.
Yeah.
And I have to say, there's a special moment in your life when people are sending you very stroppy emails with photographs of ditches.
Yeah.
And you're kind of going, I've never dug a ditch. I don't actually know if that's a good or bad photograph.
Yeah.
But yeah, no, so it's been an interesting career. I must admit, when I came to Innovate UK, I thought it was my third career, and very quickly Faraday came along and brought almost all of that together in one.
So you were there before the Faraday Challenge kind of was born as an industrial...
So I was there as Faraday was being muted, I guess.
Okay.
We did some work back in the day in the advanced materials team to really look at what materials developments were needed. It was really obvious that Faraday was going to be a massive, what's the word I'm looking for? A massive flagship for British advanced materials if we could land it. So we were very heavily involved. And I got asked to apply for what was then the interim director and became deputy director from there.
Yeah, you've been there for a good few years now. But so the listenership of the podcast goes far and wide and beyond just the UK, and actually even some people in the UK might not know. But so Innovate UK, explain to the world what that is.
So I think the easiest way of describing it is it's the UK government's innovation agency. So the normal job is to fund the most fantastic collaborative research development projects somewhere around TRL 3, 4, 5, 6, possibly 7. If you use that terminology, it's not the easiest. But actually, really what you're trying to do is take research from university benches and pull it through somewhere where it's closer to commercialization, where you can get, for example, for batteries and for EV batteries and for things like motors and drives, you can get it onto vehicles and into those sort of products that it's really hard to do, as you know, Ryan, without any sort of de-risking from government.
Yeah.
And the way that it makes sense financially for government is to sort of get consortiums of companies together so that the SMEs are working with some big companies and the big companies are working with some fresh talent. And you really sort of start to bring things through.
Yeah.
So that's what Innovate UK sort of does. What I liked about Faraday was actually something slightly different. And I think that probably goes back to my background in the Environment Agency as well, that it's a real mission. So it's not just about doing the day job of Innovate UK. It was thinking wider and broader on what the UK needed.
And it was quite an interesting thing. And I mean, actually in itself, that the government spent a bit of time thinking about an industrial strategy. So, that was good, tick. And then created these challenge funds, like very targeted funds. So there's a few of them, and Faraday is one. But basically the government said, you know what, the future is electrified, at least, if not electric. We're going to need knowledge, capability, capacity in battery systems development, manufacturing, right through. And they created this thing to try and stimulate that or support it, or a bit of both.
Yeah, I mean, it just felt like the right thing to do. I don't know about you, but sometimes when I spent so long at that point in government, what sort of government treading water looks like, and they're sort of doing the right thing. But where you need a leap forward, like we did in batteries, right? We have really strong academic base. Having invented lithium ion in the UK, we had some exciting companies like yours, Ryan, floating around the place.
Yeah.
And we had some good, a decent sized automotive industry. And you could sort of see that you were heading towards a cliff with the CO2 emissions. But actually the UK needs to do something different, right? You couldn't just solve it with the tools you had. And so actually that industrial strategy, those challenges, it's been immensely exciting to be part of what we know in Innovate UK as the Industrial Strategy Challenge Fund. But it's that mission-based approach. I mean, one thing I learned on a night shift when you're trying to roll a record or produce a record tons of steel is you have to really get creative. You can't always just do what you've always done. You've got to see different ways through. And I think that for me, it was a bunch of engineers trying to own the problem rather than government officials trying to tell everybody what to do. Yeah. And that for me really made sense.
Yeah, it felt a bit like a watershed moment actually in the UK, which to a certain extent they seem to have moved away from a little bit. But you had, like you rightly said, the government had already sort of connected with this idea of collaborative R&D, and actually that did a lot of good, helping to build out sort of ecosystem and get large companies working with small companies, and a lot of fantastic stuff happened with the sort of advent of CR&D programs. And then along came the challenge funds, which were very focused around particular areas of need, and it really changed the whole landscape. Provided a sort of such a multi-level, like a way to connect companies at to build programs, to access research, to access academia, like in a surprisingly coordinated way for something that's anything to do with the government.
Well, I'm glad it's felt like that, Brian.
It has, you just, to a certain extent, I found myself scratching my head thinking, well, this appears to have worked really well. Why aren't we doing more of it?
Do you know, I think I went into government when I left Steelworks. I went into Welsh government actually on secondment, and I just remember 2 years of thinking, what is this? Yeah. How does this even function? Like, it's insane. And I went on a training course. It's really good, isn't it? 2 years in that you go on a training course, and the guy was an old policy development Whitehall official, and he explained that the policy development cycle, and this will make all engineers laugh because he described Plan, Do, Check, Act.
Yeah.
Like, oh well, I can do that.
Yeah.
Like, really? Is that what it? And then you start to think, well, actually, is it just engineering, but with like 66 million customers? And the answer, yeah, probably it is. So some of the stuff that Faraday hopefully has been using behind the scenes is an awareness of, it's not a complicated system when you're looking at 66 million customers and all the companies and everything else. It's a really complex, fluid gap. You don't know what you don't know, right? So the only way to work in that space is to, really look at the problem, really work out what you know, but also then sense and probe. So you've got the Faraday Institution, right? Great, clever bunch of people really working on some very specific projects. But at the same time, it's also doing techno-economic research. So it's also trying to work out what's going on out there. So you're constantly trying new stuff, expecting failure as well as you're doing that, doing some stuff at speed, and then going, actually, that bit hasn't quite worked, so we'll pull that back in, reinvest the money. And that was through FI, collaborative in CR&D. We've done a bit more of that. We have actually stopped projects that we thought weren't right, or but on the whole, actually, people have really got it. So that's the expanse. You have to be more open innovation headset to really understand that space isn't going to be perfect. You're going to have to be creative. And it means that actually that's sort of like just doing a project plan and sticking to it.
Yeah.
You can't, you're not going to win that way, right? Because that's where you know what you don't know, and you get somebody in to do the clever stuff, right? Yeah. You don't know, and you can, so it had to be something slightly different. So you'll have seen that all the way through. And Investor's a good example. I mean, you and I spent a lovely morning in the London Stock Exchange with a fantastic, brilliant event right at the beginning.
Yep.
And I think we had 2 or 3 investors in the room. Whereas, now we've just run another investor showcase and there's like 30 or 40 highly excited investors in the room. And you're kind of going, you've got to learn, you can do your best. And that was a really great event.
Yeah.
But it didn't quite tick the boxes, or it was a bit premature. But we learned from that, right?
Well, obviously time has moved on. People get it now a bit more.
Yeah.
But I think they also get it in terms of at the time, because you went to investors and I think there was multiple problems that the battery market was not really an exciting one for investors yet. But also B, they were like, the government thing, that doesn't sound like something that's going to be very interesting to go to. Like, nothing good comes out of the government. And people hadn't seen that happen yet in terms of, I'm even more cynical, actually. I think what's really moved that needle as well is pre-COVID and pre-Brexit even possibly. I think your safe bets for investment could have well been into your internal combustion engine tech, into your aerospace. Yeah,
I think exactly. Oil and gas, perfect. And I think people's understanding of perhaps risk has changed.
Yeah.
And those, we talk about green investors, and now I think actually more and more they're investors. And at that event actually last week, that what really surprised me, there was more than one investor who had an environmental science background, because they wanted to make sure they weren't getting caught out by greenwashing either. So really interesting.
Yeah.
Sort of, as you say, that education piece is really great there.
So we've kind of dived right into the challenge, but I think actually it would help just to set the context for people of the Faraday Battery Challenge. So we've sort of talked around that a bit, but what would be your elevator pitch for what the Faraday Battery Challenge is and what it's got in it? Like that's...
Okay, I'll go for it. Okay, so the Faraday Battery Challenge is really all about getting the right stuff to happen for batteries in the UK. It's just simply put, that's what the government, that's what this team of people at the centre are trying to make happen. And we've done that through bringing forward and setting up an independent virtual institution called the Faraday Institution, which has funded somewhere around 500 researchers in the UK into some of the best, most exciting sort of projects out there, from battery safety to next generation materials to battery degradation to recycling. You know, actually, the whole spectrum is pretty much covered by the Faraday Institution from a university point of view. Some of the best research in the world, I think, now going on, and it's based in 22 of the UK universities. We've done a lot to really proactively encourage them to work together, encourage them to work across different departments, and really answer the question that industry needs, rather than, you know, just the blue sky. Now there's pros and cons to just the blue sky, but like for this moment, we wanted to really have this focused application-led approach. In the centre of the challenge is another funding group, which is the CR&D, and we've got well over 140 projects that have been underway or are underway. And it's around we spent over 90 million on that. The Faraday Institution have spent about over 110 million over the last 5 years. And actually, the CR&D is sort of pulling that research from the Faraday Institution, in theory, through to more commercialization, industrialization sort of steps. And what we see there again is just some of the most exciting research, and it can be from battery cooling materials that Em and I have been working on. I'll try not to go into too much depth. Go off on CRD, but they're basically two funding routes, right? So it still comes down to people. So the Faraday Institution is these 500 researchers, and what we've done in the collaborative R&D is the industrial side of that, working with research organisations and universities. But, you know, everyone from Jaguar Land Rover, Arrival, Johnson Matthey, you name it, are in really exciting projects in that CR&D. And those two pillars are fantastically exciting, but stuff we kind of know how to do. The bit that also is just a real piece of this jigsaw puzzle is the Faraday Battery Challenge also has this final pillar, which is the UK Battery Industrialisation Centre. And the bit that I did learn on the steelworks is you could do all your R&D and you can do it to death. But the moment you run at full manufacturing rate and you run your first big order through, it can all go wrong. I had a lovely example of that with a Nissan steel that we pulled through. And I'm pretty sure they didn't want a leopard skin printed version of it when the first 1,000 tons went through, and the silicon we had added to just slightly harden the steel after painting actually migrated to the surface and created a non-stick effect.
Oh, nice.
The Battery Industrialisation Centre really is this 100 engineers, this facility that can produce you pre-series batteries, but you can take your materials there once you're at a high enough TRL, and you've got enough of them to really test them through. So it's a prototyping facility that can help you do things. If you're someone like Britishvolt, you'll may see news releases where they've been using UK BIC to trial their cells and produce their early cells so they can show customers what their product's going to look like as they're building their gigafactories. It also means you can train staff, you can try things, and the whole site is set up for that flexibility. And that's 130 million plus of government money that's gone into something that for me is a real win. We get so much feedback from talking internationally, you know, from the States, for example. You know, you're kind of going, this is amazing. You know, you've got somewhere we can. So you have interest now from a lot of international companies looking at the UK, and I think I think it's the fact that it's ready. In a moment where, you know, everybody else is trying to catch that up, and there are others like FFB in Germany is coming, but it's probably 2 or 3 years behind where UK BIC has been.
It was sort of UK BIC was a unique concept in the world at the time that it was put together, wasn't it? Really, of that kind of, obviously not academic, because you can't. It's all about making stuff at a scale. But the problem with battery manufacturing, a lot of people don't really understand this, but when you go into a battery manufacturing plant, it's either sort of lab based, like not scale at all, or it's really at scale, sort of like moving like the speed of light to put stuff together into battery cells, and there isn't really an in between.
No, and actually the in between is really difficult because actually when you're running a gigafactory, and you're creating these, millions of cells, actually what you can't do easily is run trials, put any variation into it, because as soon as you do that, you create yield loss. So as a manufacturing engineer, that's your worst nightmare, particularly when you're putting in exceptionally expensive materials. So your yield loss becomes something that potentially could invalidate a vehicle.
Yeah.
So actually to run trials and things like that, you really need to be able to have somewhere you can go that's flexible, to try on new materials, try on new setups, try on new techniques, for example, on welding or anything really. Because once you're making those cells, you need to be in stable conditions for it to make money.
Yeah. And that sort of dedicated manufacturing plant that's like banging the same thing out, where that consistency and a lack of you can't have any distractions, basically, that's super critical. And I think the battery industry is probably like unique because of its stage of development, where you're transitioning from like consumer electronics type batteries to these more higher level propulsion battery systems and things for electric vehicles and other applications where there's this huge
huge. And it is I guess it's one of those risks that actually all materials companies and chemical companies can fall into very easily, because you're making products at scale in the millions or of whatever of units, and actually you've invested in really expensive kit. I mean, these are gigafactory. You can see the bill for building a gigafactory, and they well over a couple of billion quid, right?
Yeah.
Even a small change to your process is going to set you back tens to hundreds of million, right?
Yeah.
And actually that's not dissimilar to steelworks, it's not dissimilar to chemicals, it's not that dissimilar, right? All of those processes that require that sort of consistency, those units will cost you that much. And it's really interesting to then have somewhere in the UK that actually bridges that gap, because it's very easy to stay in your safe, you can to make the argument you can't invest in something that's so significant. Because actually you get into where the prices are driven down, because you're in an economy of scale business as well, in that. So it's a really exciting tool for the UK to have.
To help, because like you mentioned earlier, which a lot of people I think don't realize, but lithium battery cell technology was sort of the concept originally came out of the UK, but was never industrialized in the UK. So we didn't develop a battery manufacturing industry at the time. It went overseas to, all right, was it Sony that commercialized it?
It went to Japan, didn't it?
Yeah.
I love this story though, and it all comes down to the fact the application was actually in Japan, but also because Sony was decommissioning cassette tapes. And when you look at how cells are made, battery cells are made, there's a lot of winding. So I don't know, you're my age, so you must remember taking a pencil to a tape deck.
Yeah, definitely. Yeah.
And actually, those thin films that they were producing then, they had a lot of engineering, a lot of NASA, a lot of plants. So they invested billions, but it was all to do with Sony camcorder batteries. And I don't know about you, but I do remember those being the first proper rechargeable products on the market, camcorders. So the story so the story goes. And you can see why the UK then would be looking at its automotive industry and going, we've built this up. It's a really great industry. The UK is really good at actually making vehicles move, that propulsion, making them go fast. If you're more motorsport background or love, like I do. But it's that differentiator for automotive is how it feels to drive. And so that's one of the reasons why we were looking to emulate that success. It's because the application this time is closer to home.
Yeah, and sort of interesting, because from a battery production point of view, we did actually then end up with, albeit on a smaller scale, but as I love pointing out to people, still technically a gigafactory, but we ended up with, so the battery industry, because we're talking about the creation of lithium, or invention of it is 30 plus years ago, and then Sony commercialized it, and we're still talking quite a long time ago. But then more recently, but still 10 years ago, maybe, it came back. So Nissan built a battery manufacturing plant, so a small gigafactory in the northeast in Sunderland to make battery cells for the Leaf. And I guess that plant sort of almost typifies why something like UK BIC was needed. In it, it's that very, very focused, manufacturing plant. It has exactly the right number of production lines and bits of equipment to do exactly that job with no excess at all. Right. Certainly couldn't, but it did create some skills and expertise in battery manufacturing at scale in the UK, which has then been useful in terms of pulling across into UK BIC.
Yeah, it certainly built an expectation that we could, if we really put our minds to it. Yeah. And I think that's the piece, isn't it? Very often for us engineers is we can argue normally till we're blue in the face on what we should do next. But that moment where you can go, well, actually they can do it there, so we must be able to do more. One of the examples actually that really stood out to me, which was one of those moments where you realise actually the UK is nowhere near as shabby at the start as you would imagine, was we were struggling with things like, when you look at UK BIC, what the codes of practice should be for it, because actually they were using new equipment, but actually nowhere in Europe where they're producing cell materials. So we got together the British Standards Institute, and we got a group of cross-industry sort of specialists together, and we started developing what was called a PAS, a pre-standard, but really just a code of practice, trying to write down what we did know and about what you should do in terms of health, safety, and environment when you're handling, manufacturing cells and electrolytes, so that UK BIC had something to show insurers and get a warranty and get and be able to move forward. And it was the one we were really worried about, right? Cells and electrolytes, because whilst the gigafactory at Sunderland, actually it wasn't doing the cell materials. So and we really wanted to do that.
Yeah, that's true. And that's sort of when the bulk materials come in there, don't they? Do they come in from Japan, or are they coming from outside the UK? Basically,
they come in from outside Europe. Actually, I think on the whole. In fact, a lot of the gigafactories that were originally set up, the one in Hungary and the one in Poland, again, that a lot of the black mass powder coming in would be coming in from somewhere else.
Yeah,
from the Far East in particular. But yeah, so it's like, well, how do we do that? And what was really interesting is I was thinking, I know nothing about this. And then you open up the PAS and it's all stuff like COSH and REACH and actually all these things you do know, and you realize actually there's a huge wealth of knowledge in how to do this right.
Yeah.
It's an area that we haven't done before, but it's not an area that is dissimilar to some of the other things we do here. No, and that's the piece that I find really exciting.
Yeah, well, it strikes me as it's been an era. I mean, obviously, as listeners will know, I've been involved in the electrification industry since 2004, 2005, which is like a depressingly long time ago now. And I always sort of struggle. I don't feel old enough that it's been that long, but it has. But it's now, because it wasn't the right time then. It was a bit too early. People used to quite openly laugh at it, but we're now having a bit of an industrial renaissance off the back of it, because actually the kind of levels of investments that we're getting into the UK and into building new capacity in, things like British Volt, in the new Nissan plant. So Northeast has benefited greatly from this, but these are like multi-billion pound investments, which I don't know if it wasn't in my space, so I didn't see them, but it feels like for a long time we've been decommissioning large plants and large kind of capital intensive operations in the UK and kind of sending them somewhere else. And the steel industry is a really good example of that. But this has now become something where, actually we're investing really heavily, like billions of pounds of investment plus inward investment from outside the country. And maybe we're at a bit of a turning point in terms of that a kind of renaissance.
I hope so. I really hope so, because let's be really blunt, right? We need one right now. We really do need one right now. We need it from an economic standpoint. We really need that. But we, post COVID, and where the country is right here, doing something that builds something that's better for the world, better for the UK. It's certainly something that keeps me getting up in the morning and coming to work, because it's such it's so much more based on what the UK can do moving forward. And don't get me wrong, right? I know I'm from steel, right? So and I love it. I think it's an amazing industry, but it is perceived to be old, whereas actually I used to work in Port Talbot, still one of the world's most efficient steel works in terms of CO2 per ton.
Yeah.
But actually we know we've got to change. We know we've got to do it completely differently. And how do we do that? And I think actually in all walks of life, that is potentially where the UK can really do something creative. And we are, as a bunch of engineers, quite creative, right? It's one of the reasons why, I don't know why our education doesn't quite beat the creativity out of our engineers, but it doesn't, right? And I think it's really exciting that we do that. And I think that's one of the reasons why, Nissan, for example, have stuck in the UK, because actually the way Japanese systems-based thinking, statistical process control type approach, actually mixed with that creative problem solving, engineering from the UK, it's where we can be really strong. And we need to move. And I hope that we can continue to do that. It's difficult times at the moment for the government, for example, because we're changing again. So whether new policies will come forward or not, we wait to see, right? But actually, it has been a pleasure to work on one like this for the last 5 years, because it has felt like the right thing.
Well, and consistent over a decent period of time to do some really good stuff. And unfortunately, it did feel like the sort of the sands was shifting a little bit against these organized challenges, but they have done a lot of good, and really changed the approach in the UK, much more coordinated, big picture thinking, and that realization that actually we have to make stuff that is important. There's a strategic value to this. We can't be an entirely service-based economy.
I agree. Whatever it is in the future, Ryan, in terms of policy making for the UK, I do think we have changed expectations.
Yeah,
I think the industry will expect government to think much more around this mission approach. Not just setting things up that can just run and do the same old thing, but things that actually really do look to make a change. And I look back over the 5 years, and the difference in the ecosystem for people like Britishvolt, right? So you're right. They've been around just over 2 years. Phenomenally exciting proposition. Do I think they would have been even stuck in the UK, because whilst they're called Britishvolt, there's nothing that actually
they didn't come from the UK. No,
they didn't come from the UK, right? So but there's a real passion for UK, and I have to say Isabel Sheldon at the forefront of it in terms of its direction. But it's the UK that's actually attached to the UK, and seen them move to break ground on the Blythe site. And for me, that's that whole thing at every level shifting.
Inconceivable 10 years ago. Inconceivable that could have, if a big player like Panasonic had come as an pure inward investor, maybe, and it might have got some support, might not, but but this, in terms of the Britishvolt journey, it is inconceivable that they could have done that 10 years ago. The whole, it's not it's not just the Faraday challenge, but there's a lot of things have changed in terms of the world and investor appetite for this stuff and But it really it's incredible and a fantastic thing for the UK, and very pleased to say.
You were talking about industrial renaissance. I mean, that has to have vision, and I think that's you talk to people in the UK, the vision is a shared vision. Your vision for Avid and where you're going is solely yours, but you understand and see how it fits alongside that bigger vision, and you will make decisions that are right for your company, but you can see where it's going, and that reassurance for investors, for inward investors, actually does come from government commitment and continued commitment, and we're really looking at the next 3 years in Faraday as well. So it needs to keep going. We're so close to tipping over the edge, I think, and it being self-sustaining. But it does take a few more years. I mean, it's such a vast challenge technically. So when we originally sort of discussed doing this podcast, it was going to be, I mean, almost like a bit like a desert island discs of looking back on the your greatest hits. So what, in terms of that history at Faraday, what have been the real kind of notable moments for you? And looking back, what are you most proud of that you've achieved? So if it's for me and what I've achieved, it always comes back to the people, right? I mean, from the moment you kind of sat down with the 7 universities at the heart of the Faraday Institution, the sort of founding ones, and people like Peter Bruce and Claire Gray, and you're seeing them now as Sir Peter Bruce and Dame Claire Gray, and just because the vast leap forwards that they have been doing in their work. But it's not in isolation, it's across Bath and Southampton and Birmingham and Warwick and Edinburgh, and I'm trying to think of all the Lancaster, and you're seeing that in the university space bring forward some really rapid sort of research that's already out there in the market, right? It's not just been lost. You've seen IP that's sort of getting harvested faster, quicker, better, and you're seeing the institution having a different pace on how that IP gets to market with its sort of T-scan methodology, and it's a very different beast to what existed before. So it's the people involved, and it's the way they're working in the FI, and ditto for the CR&D, from everything from how we work with investors, hopefully over the next 3 years, moving to a sort of an investor partnership approach, but equally continuing to support SMEs, get better at pitching and understanding what they need as business propositions to pitch, but also, unlike, as you said, back in 2004 you started, or
2004,
I can only imagine how many deaf ears of investors. So teaching people to pitch, but also having people for them to pitch to, that are really excited about what you're doing. I mean, what an exciting place to be. But it's also the systems base. We've got battery fire safety, right? So electric vehicles are, however you look at it, on a vehicle level, as safe as internal combustion engines, but it's on the system level as well. So it's all of it. It's charging in buildings all the way through to recovery on motorways. And we've got, you've got the chief scientific advisors for DFT and BASE, leading work on this. So we've got this cross-government piece. We've got the same on sustainability, from DEFRA to the Health and Safety Executive and Environment Agency, making sure that the recyclers, for example, are compliant, and we're working together and making sure that is coming forward, so that, again, there's just more success for the long term in the UK. You're seeing a real rapid change right the way through, and that, I think, is what excites me, because there's a lovely description actually on that training course I told you about of what government felt like. People would always complain it's like banging your head against a brick wall. And this guy said, no, it's a super tanker, right? So you're banging it. So if you bang your head on it long enough, it'll do a U-turn. But it might take you, 15, 20, 25 years to do that. So when you're writing to your MP, write, because if it's something change you want to happen, it will happen even if you're not getting the responses. What's really interesting though is when you find those tugboats, and that is what Faraday feels like it's done. It's set up this tugboat in motion, but then it's brought alongside it the Automotive Transformation Fund, its partners in APC, its partners in the aerospace. Sorry, APC is the Advanced Propulsion Centre. The Aerospace Technology Institute. We work with catapults. We work with lots of different research organisations, and those pull technically to sort of say this is the direction of travel, this is where we need to go, is moving this super tanker, right? And that's what it feels like at the moment. And you add the UK BIC in there, and you've got somewhere as well to get that final bit of industrialization through. It just feels like we are at that moment where you're going to have gigafactories here that work well, are engineered well, that have skilled workforce coming towards them because they can see how they can get there, and they can see careers in there. And it's that I look back on and go, that groundswell. In fact, a long time ago, someone told me that the Faraday Battery Challenge was like a movement. I quite like that. That it feels like I'm doing my job right. If I have 66 million customers, and somebody's describing that, surely that's sort of where we're going to, right?
No, I think that's a really good way of putting it, and it is if you're trying to do a very substantial change to an industry or a new industry, it is such an interconnected, interwoven piece, because you're not going to get the investment and the factory without the skills and the people. You're not going to get the skills and the people without the opportunity, or perceived opportunity,
And it's been every corner of the UK getting the problem and working out how they can be part of that solution. What is it? What is in it for them? And it's not that they'll only be solving that, electrification. They'll be doing other stuff as well, but it's how can it all pull together? And it's because people have that line of sight, I think. And I think that's just immensely something I'll always be proud of for Faraday.
And if you had to, thinking back over the last few years, I don't even know if it's possible. Like, if you had to pick a few of your favorite moments, projects from the last few years, could you do it? Are there some standouts?
That's really unfair in that there's so many standouts.
Pick your favorite child.
Which is my favorite child? Well, I love the recycling stuff. I love the sustainability stuff. I think there's been some really brilliant breakthroughs, and not just in Faraday funded stuff, but actually APC funded stuff, things coming out of Recoverist Project, for example, things coming out of Relib. They're always very close to my heart. I'm an extractive metallurgist at the end of the day, so I find them immensely satisfying. I'm always going to come back to materials examples. Apologies. I remember going to the Materials Research Exchange in 2018, I think it was, organised by the Advanced Materials team that I sort of just left, and Rob Corshey and the KTN team. And it was a fantastic event, right? And I met this company there called M&I Materials. And I just had a random chat with one of them. And from that, they were developing cooling liquids for transformers for the grid. And actually now that's one of the most exciting sort of cooling system products, right? And it's a small UK company just outside Manchester, I think. And they've done this ICABAT, that sort of thing, that chance thing where people just got what you were working on, and have come up with such brilliant ways forward. They partnered with Ricardo, for example, and WMG, and they sort of they've started to sell it to like a company out in California, right? And for you as well, I mean, things like when people are talking about cooling systems, and you can see that they could work for batteries, but they could work for motors, and you start to go, that's really exciting. So that's some of the standout. But also the first time I went around UK BIC, I was just like, oh, I just want to stay. Can I just work here? And because it's in some ways it's really similar to automotive galv steel. You've got these strips of materials getting coated and dried, and I just was, the scale of it and the excitement of it and the precision of it. That as well. That's a real standout moment, seeing that place as something that is pulled together so many pieces of equipment into something that can make millions of cells and batteries. It's a really that also shines. Do you know what? It's really hard. So going up to Ampthill for the first time and seeing a battery factory for the first time, that was immensely exciting. Because the familiarity of it is really strange, Ryan. I mean, I think that's one of the messages. If anyone's listening to this and they're an engineer and they know nothing about batteries or anything else, I'd challenge any engineer who's worked in a manufacturing industry like chemicals or steel or anything, not to feel it, feel a sense of familiarity when you get there. It's never. It's one of the reasons I think they're keen to open up and let people come visit who aren't in that space, because you'll be shocked. I mean, from food mixing to to coating to everything from rolling, right? So I'm from a rolling background. Temporary rolling on steel mills was a bit of a speciality at one point, and calendaring batteries. You're kind of going, this is amazingly similar. So those moments always stand out to me.
It is an interesting kind of hybrid of the sort of that clean room manufacturing environment, very sort of controlled atmosphere. For me, that was a bit alien, getting suited and booted up the first time I went in a battery cell plant. But then, when you're in there, it's kind of like, oh, this is this.
Oh, we can do this.
This real to real process. It looks a bit like I've sort of seen sort of paper manufacturing and things like that before. That's kind of where my
definitely
real to real. But any those sort of it's a high volume, high process quantity, but very precise, very tightly controlled manufacturing.
That's the piece as well, Ryan, that always hits me sort of between the eyes, because I come from that manufacturing background, that large industry, heavy industry background. When you start to see companies like Ilika, talking about having their whiteboards and, basically all their visual management techniques, which is so manufacturing. Or when we're putting out a competition requiring people to demonstrate their environmental compliance. These are core to the principles of large scale manufacturing. These are core skills. Things like UK BIC getting its first permit, looking at places like British Volt getting their COMA sort of work done. And you're kind of going, this is actually the bit where you're really keying into an infrastructure that is right, and going to be safe and going to be done the right way. And that really excites me as well.
So that could be that might have been the answer to my next question, but just to sort of, I guess to round things off, because I just a little time check, and we're nearly out of time. But your next, so in terms of what you're excited about, in the future. So I often ask people, what is it they're most excited about in the next sort of 12, 18 months, with or even longer term? What is it about the future that's happening in the UK battery scene, or the Faraday challenge, or that space that's got you most excited?
So there's always a fragility, isn't there, when you've got one big player or two big players. So I think we're entering, when we look back, Ryan, you're going to laugh. We started off with a slide that was titled "Why Batteries." You would have seen that slide many times. And then it was like, batteries are coming. And then it was, batteries are here. And now it feels like we're in the rise of the gigafactories, right? And I think anything you see with big announcements about, additional capacity in the UK for gigafactories, and their supply chains. That really excites me, because that's where you're moving, your transition. That's where you can see that future in sight, that it's a really self-sustaining prophecy. That excites me massively for the next 12 to 18 months. Recycling technology is really coming to the fore. That really excites me technically, that piece, where you're moving from to something that is much more akin to a tier one, automotive supply chain sort of philosophy for recycling. That really excites me, where they're working with second life producers as well. So they're really, really intelligent, thinking about that post first life approach. That really excites me. But in the really immediate term, it's how many people are going to apply to round 5 of the Faraday Battery Challenge.
Yeah.
It's going. I think it's going to be an immense competition, and so exciting. And all the companies that we have sponsored previously have worked so hard in terms of their growth and their knowledge, and we see them coming back, but we also see new ones coming in. So I won't tell you who it was, but somebody told me they were going to have a blitz attack on round 5. And I'm laughing, thinking it's great that people are really thinking about how they can muscle into round 5, but it's 25 million, right? And some of the bit that really excites me is when they don't get funded and they still absolutely deliver on innovation without government money, because competition is a slightly artificial construct, and your timing might not be quite right, or we put requirements on, and which aren't always the right thing for the individual companies. And when you see those individual companies move anyway, then it's more than just waving money at people. It's because they're really committed to it.
Yeah. That's excellent. I think that's about all we've got time for today. So there's a couple of things that I had on the list here that we haven't managed to talk about, like the fact that you are a visiting professor at the University of Leicester, but we managed to get around to that. But thank you very, very much indeed for taking the time out to come and talk to us today. It's been really interesting. I'll put some links in the show notes for people who are interested in the Faraday Challenge and what it does, and also some different ways to get in touch with Jacqui. But that's been great. Thank you.
Thank you, Ryan. Lovely to be here.